All right, guys, section 10.8. Continuing on here with the graphs of polar equations. Again, technically, today, again, I say today, we're going to get through part of it today, part of it tomorrow, which is why that quiz is getting bumped a little bit. So, LIMACONs, there are going to be 4 types of LIMACON. Some students, again, obviously I want you to make your own judgment here, but I'm just saying historically, in past years, a lot of students or some students have said that LIMACONs are a little bit easier. They kind of start to get the feeling. It may not seem that way initially. I'm saying kind of long term by the time it's all said and done. Again, I don't want you to go into this with the wrong mindset that, oh, these, Clemenger said that this might be easier, so that means we're not going to have to do much work. There is a tedious aspect to the LIMACONs because we have to create and these T-charts and absolutely continue to plug in, and keep on going and finding some stuff. So, and again, that just takes some time. But the nice thing about the LIMACON is that, as again, I'm just speaking off of past years, past things that I've heard students say, is that, and again, maybe this is where you're at with rose curves, but some students have been like, I always feel a little uneasy, like, am I doing this right because it's a cosine, or am I doing this one right because it's a sine? Because we had to approach the problems differently for rose curves if it was sine or cosine. With LIMACON, it doesn't matter. We're literally going to do the exact same thing every single time. Now, our end product, the look of the graph, we're going to have 4 different outcomes that this is going to look like. But again, we will approach this the same way each and every time. All right? So the goals that we have in mind here, very similar to what we had in mind for the rose curves. Students be able to recognize special polar graphs. Students be able to interpret and understand the parts of a LIMACON. That's going to be the big focus for today. It would be 1 and 2. And then eventually students be able to use symmetry, zeros, max R values to sketch in these LIMACON. All right. So yesterday with the rose curves, we were working with the unit circle, which is why we put it up there. With the rose curves, it was really all about we've got to know our angles. We didn't really touch anything with the coordinates yesterday with the rose curves. It was all about, can you correctly identify where pi over 6 is? Do you know where pi over 3 is? If you are at pi over 3, could you add 2 pi over, those types of things. That was the type of work that we were doing with the unit circle. I would say that now with the LIMACON, we're going to be using not just the angles, but also the coordinates. But the trade-off there, the good news is that we're going to be focusing on what I would assume you have, kind of mentally created as the easiest points. Again, those are going to be the points that we're going to be focusing on and caring about. Now, I know that I just circled 4 of them, but we're going to call them 5 points because we're going to use theta equals 0 and theta equals 2 pi as slightly different points. Okay, like I said, it's all about the limit that we're approaching and things like that, which we will talk a whole lot more about in chapter 12 after we take the final and stuff like that. All right. So that's important enough to where I actually drew that up on the marker board, on the whiteboard. So again, we want to be able to point and reference back to this over and over throughout the next couple of days. So here are the LIMACON equations. Couple things that we want you to notice. Number 1, you see the plus or minus symbol. It's, again, I just didn't want to write the equation. I didn't want to write 4 equations up there instead of 2, I guess. It's not going to be a plus or minus symbol in this aspect. It's either going to be an addition problem or it's going to be a subtraction problem. Does that make sense? It's not going to be the plus or minus symbol and you've got, I've got to apply both. No, it's going to be one singular equation that is either addition or it is going to be an entirely different equation that is subtraction. All right, so what else are we noticing is different about these LIMACON equations compared to the rose curve equations that we were working with previously? Say that again. Variables? Is that what you're saying? The A and the B? Absolutely. We had A and N when we were working with the rose curves. Again, here it's A and B. I thought I heard someone say adding. Maybe not. Maybe sometimes I hear what I want to hear. But again, yes, we have addition and subtraction in place here. Yesterday with rose curves, it was all about multiplication. So again, those are the big differences. Again, it's no secret. I know you guys could look at. These are the 4 different types. This is what they're going to look like. again, we have what we call an inner loop, we have a cardioid, we have a dimpled limacon, and then we have a convex limacon. So these are going to be the 4 types that we have. All of these are horizontal, all of these are pointing to the right. So as you hear us, reference, oh, this is a vertical, or this is horizontal pointing left, this is vertical pointing up, those types of things, that's what we're talking about, and obviously we'll touch on that a lot more as we go. But understanding those variables A and B, that's going to be crucial. A is the constant that is out front, that you're going to be adding or subtracting. B is going to be the coefficient that's in front of the trig function. There, again, I'm just remembering questions that people have had in previous years. What if we ever have a coefficient in front of theta? And my argument there would be that, well, then it's not going to be a limacon. So again, we will not have that situation arise, because again, we're controlling this in a way such that we're only going to actually graph limacon. So why would we throw something in there just like, surprise, this isn't a real thing? So no, we're not going to have to worry about that. It's all going to be about the A and the B values. So what do A and B tell us? Now, first thing that I would highly encourage you to add to your notes, again, just to clear up any confusion that may potentially happen, let's think about this as the absolute value of A plus the absolute value of B. When we add the absolute value of A plus the absolute value of B, that's going to tell us the maximum R value. Okay, now the reason why I want you to put those absolute value symbols is that what's going to happen as soon as we see something like 5 minus 3 cosine theta, something like this, someone is going to jump in there and immediately say that A is 5, B is -3, 5 plus -3 is 2, so the max R value is 2. And it doesn't seem like you're doing anything wrong, but in this particular case, and I know this seems to go against so much of what we typically say, B is at -3, B is 3, okay? Whether that's an addition problem or a subtraction problem, B is always considered to be the absolute value in that slot, all right? So in this particular case, we would say that A plus B, 5 plus 3, the maximum R value would actually be 8 in that situation. Does that make sense? Do we see the difference there? Okay. Or like in this first example, I'm going ahead here, sorry, I'm jumping around. But like in this first example, 4 plus -4, seems like the maximum R value would be 0. Well, that'd be a pretty interesting looking graph because everything's just going to be there and it's never moving. So no, that's obviously not going to happen. So again, knowing and having a plan for how to handle that. Again, so please make sure that we've added the absolute value symbols there. So again, absolute value of A plus absolute value of B. That's going to tell us the maximum R value. That's going to tell us the furthest distance, excuse me, from the pole that we're going to go. Also, A and B, we're going to create a ratio. That's going to tell us which type of limacon we have. Like I said, we have 4 types. We have the limacon with the inner loop. We have the cardioid. We have the dimpled, and then we have the convex. Those are going to be the types of limacon that we have. Depending on what A over B gives us, that's going to dictate which of the 4 types we have. Now, once again, good news. Remember what I said a few minutes ago, that we do the same thing every single time. It's not like, oh, I noticed this one's an inner loop. I'm going to have to do this totally different than that one over there that was a cardioid. We do the same thing. It's just that your graph ends up looking different. Does that make sense? Okay. So that's again, more good news that I suppose that we have as opposed to limacon compared to the rose curves, is that we approach it the same way each and every time. But that's what the A and the B are going to be all about. Again, we're going to create that ratio, always A over B. That's going to drive the graph, I suppose. Really contemplated taking this out, this next part. Again, because you're not going to be able to use graphing calculators on the quiz. Also, not everybody has a graphing calculator. But again, this is more for a homework. How can you check your work? But you can use the tracing features on your graphing calculator, and it can be very helpful. If you're using Desmos to check your work, things like that, you can use those tracing features as well. So that's what I was getting at here. A couple of other things to know is that limacons that are cosine are considered to be horizontal, meaning that they're going to point to the right or to the left. Limacon that are sine or with a sine curve or function, excuse me, they're going to be vertical, meaning that they're going to be pointing up or down. Now, if we have a cosine addition, it's going to point to the right. Cosine subtraction is going to point to the left. Sign addition is going to point up. Sign subtraction, it's going to point down. But once again, and I really want to stress this, you don't do anything differently based on this information. The reason why we point this out is a way that we can go back after the fact and check our work and say, all right, this was a cosine addition. It should have been pointing to the right. Yep, there's my graph. It's pointing to the right. I did everything the way that I was supposed to. That's what it's there for, okay? It's not so much, all right, I'm noticing this is a cosine addition. Oh, I have to solve the problem this way. And then the next one was cosine subtraction. All right, scrap that. I'm going to solve this one different. No, it's the exact same. The exact same. All right, so once again, these are the types that we have. The way that we're going to get there, I suppose, is that if we find that fraction, that ratio a over b, to be less than 1, we will have this inner loop. Now, one thing that we want to point out here is that I want to draw your attention to, because I would say that the #1 biggest mistake that students make on the polar graphing quiz that we're now scheduled to take on Monday is that when students draw the inner loop, which I realize we've done 0 times so far, but I want to get out in front of this, is that when we draw in the inner loop, we have to cross through the pole. We have to. Like that, the inner loops, they're going to go through the pole, no matter what. Okay? So again, if we're not going through the pole, if we miss the pole, then we miss the ground. Again, what we mean by that is that some students will draw it in looking something like this, and they'll, I'm about to screw this up, sorry. And they'll draw it to where maybe we do something like that. Again, we missed the pole. We drew that incorrectly. And I know it seems like a minor, and he's being nitpicky, things like, in some regards, yes, I am, but it's also not an inner loop if it's not going through the pole. Okay, it has to go through the pole. That's arguably the most important part. Okay? The cardioid, that's what we were going to have if when you find the ratio a over b to be 1. Again, a divided by b equals 1, we're going to have this cardioid. If we find that ratio a over b to be greater than 1 but less than 2, that's when we say that we have a dimpled LIMACON. Now, I would say that when you're drawing these, this is about the only time that we have to do anything differently in our sketch, because you'll notice that the cardioid distinctly goes in and comes back out. That's what we're noticing here. And the dimpled, it doesn't have as much of a concrete go in, go out. But again, could we have the same points in the same locations and draw this to where it looks like a cardioid? We probably could. We want to stay away from that, obviously. So that's why it's going to be very beneficial to know what type we have going into it. Again, once we start to do some of these examples, I hope that that's going to start to make a little bit more sense. The last is the convex. Again, I'm sure that we remember that term convex. That, in many regards, it's defined as being not concave, so it does not cave inward at all. So again, that's going to occur when a over b is greater than or equal to 2. That's what we're going to have. All right, guys, what questions could I answer up to this point? All right, let's go ahead and try one of these. I'm going to stop the video here and start a fresh one.